Yes.
You do 7, please.
7. Okay. Okay, 7 is the moving shadow one. And we have 2 questions we're asking for here. So a 5-foot-tall woman walks 8 feet per second. 8 feet per second toward a street lamp that is 20 feet above the ground. Okay, so let's start by getting a picture of what's going on. So we can understand the situation. Okay, so we have this street lamp. And then we got this ground that we assume is horizontal. And then we got this woman here who is 5 feet tall and a street lamp that is 20 feet tall. Okay. And we're trying to figure out, and some information we have is, notice since this is the light going off, this right here is going to be the shadow that that person casts. And as they get closer and closer, this is going to get a steeper angle, so our shadow is going to become shorter and shorter. And so the shadow is going to change as they're moving. So we need to identify some variables here. I'll let S equal the length of the side. So I'm writing it cursive S so I don't mess it up with the 5. We'll let S equal the length of the woman's shadow. In feet. Okay. Something else that's changing is she's walking toward the lamppost. So her distance that she is from the lamppost will also be changing. So I can make that D equal the distance she is from the lamppost in feet. Have that changing. We were also given some other information. We're given that the 5-foot-tall woman, she walks at 8 feet per second toward the street lamp. So we know 8 feet per second toward the street lamp. Now, using our notations that I just came up for identifying the sides of that different parts of the triangle, what calculus notation would we use to represent that 8 feet per second? What is that? As she's walking?
D over D.
That's it. That's the rate in which the distance she is from the lamppost is changing. So that would equal dd over dt. So you got to figure out the rate that you know once you identify your variables. Okay, then we were also given, we were asked to find what is the rate of change of the length of her shadow when she is 15 feet from the street light. So what is the rate of change of the length of the shadow? So what would be our notation for that using calculus notation? What would be the symbol for that? The what? Okay, so we want to find the S of dt. That's what we're trying to find. We're trying to find that when she is 15 feet from the street light. So when blank equals 15, what letter? D, her distance from the street light. So when D equals 15. Okay, so that's kind of what you get a picture to see what you're going through. Read the question a couple times if you need to read it a couple times to understand what's going on. Identify your pieces that you need. Identify your variables. Identify what rate you know and what rate you need to find. So this is related rates. You're always going to have one rate you know, one rate you're going to find that you have to relate in some way. So now I got to come up with some sort of equation that relates the variable D and the variable S. Because I have to relate the rates of change I'm looking for. So that's what my thinking process is. I'm trying to find an equation that relates D and S together? Any idea what I could do? How I can relate those? Yeah, you need similar triangles. Yes, similar triangles. Because notice that this big triangle here and this little triangle with S both have right angles, and they both share this side, this angle here. So we have angle similarity. So we know that those two, this little triangle here and the entire triangle, are similar to each other. So you want to set up proportions. So I'm going to say, okay, if this length of my side, so that's my S, is to 5 as, okay, what's the length of this side of the triangle? The big triangle. Okay, so that's going to be S plus D is to 20. So that's how I relate this together. So I'm doing proportions. Got my small triangle related to my large triangle, since I have angle similarity. Okay, so I need to simplify this down, so I can just do cross multiplying. So 20S is equal to 5S plus 5B. Combining some like terms, I get 15S is equal to 5B. We can even go any farther and simplify that even more and get that D is equal to what? 3S. Come on, close. I don't want that new sketch. I don't want to snip that. All right. Okay, so 3S is equal to D. All right, so I've related my two rates that I need, my D rate of change and my S rate of change. So but right now I just have the equation. How do I get rates of change? What do I need to do with this equation 3S equals D? Derivative. Rate of change gives us our derivative. So let's differentiate this. So that's going to give us 3S derivative is 3, but S is not our t variable, so we have to times that by ds dt equals the derivative of d. That's 1 times dd dt. That's what we're looking at right now. Okay, let's look at our given information. We know that dd dt is 8. And we know that d is 15. But we don't have a d to plug in, so I just plugged in the 8. Simplifying that down. I get 8/3 here. Now, we got to think about the situation a little bit. It originally said, notice that we did that she walks toward the street lamp at a rate of 8 feet per second. And we're figuring out the length of that shadow, which is, what's our units of measurement for this? Feet per second. Now, this is the distance or the length of the shadow. Is it increasing or decreasing? It is decreasing. So you would have to recognize, even though that the rate of is changing is 8/3, when you write percentage, you'd say the rate of the, how did she state it? What is the rate of change of the length of the shadow? The rate of change of the length of the shadow is decreasing by 8/3 feet per second. Okay, so you have to make sure you do that decreasing, because this is actually a negative. ends up being on F, because you have to recognize with the situation what's going on. So our sentence would be that her shadow is decreasing at a rate of 8/3 feet per second.
So, on number 2, would since the triangle is decreasing, would the answers also be negative?
In your sentence, you would have to do with the decreasing. The answer key has a positive down there. I'm trying to say, is that the one that did? No, that was a typo. It should be a negative. Okay. There's some that said speed, and so speed is actually value, so that's the reason why you didn't see the negative on the speed ones. But yeah, 2 should have been negative. The answer's to 2. Okay. So now let's look at the second part of this question. Now it says, at what rate is the tip of the shadow moving? So new question. Now we want to figure out what rate is the tip of the shadow moving. Okay, so for this, you could introduce a new variable. I could say, let's let this entire distance here equal t, because that's going to track the tip of the shadow. The entire distance there, or s plus v, however you want to write it, you can use that notation, but it gets a little bit similar if you just do a single variable here.
You also have a t already.
Oh, t is time. Okay, so big T. Separate the two. Okay. So we're going to let big T equal the distance, the tip of the shadow is the lamppost. And B. Introduced a new variable there. Okay. All right, so now I got to figure out how to relate some of the rates I know with that t variable. So any way I can relate, say, t with s. Is there an equation we can make that relates t with s?
Plus t.
Huh?
But
But that gives us the extra variable d. We don't want that d variable. We want to get rid of that d because we want to.
S or t is 20, s is 5.
We could just do this related rate again. Okay, s is to 20. S is to 5. I guess I should write my cursive s. S is to 5 as t is to 20. You get the same proportion, right? There's still similar triangles. I just renamed that variable because here it's easier for me to work with that because I want to look at that new tip. So I want to look at that t variable. So that gives us 5t is equal to 20s. So t is equal to 4s. Okay. So t is equal to that 4s. All right, we want to find the rate of change of the tip. So what are we actually looking for here? What calculus notation are we looking for? D big T over D little t, right? So that's what the rate of change of the tip of the shadow is. And so I'm almost there. I can now differentiate this. So what's the derivative of big T? And what's the derivative of 4s?
ds.
4s ds dt. Okay, so dt over dt is equal to 4. And we found ds dt in part A, so that's negative 8/3. Okay, and then we take that negative 8/3 and we times it by that 4 and we get negative 32 thirds. So the tip of the shadow is decreasing at a rate of 32 thirds feet per second. That's how I would do that one. And next one, or any others on this one.
What's the full question? Oh, 4.
4? Oh, the swimming pool. I knew that would be asked. Okay. That was the most challenging on the paper, I think. I think number 4 would have been the most challenging. Yeah, you have to kind of think about what's going on in this one. Okay, now pardon my wonderful drawing, but I am not an artist by any means. Okay, so we have this situation going on. So there's like my swimming pool. Okay. We know this is 50 by 20. We know this goes at 1, and the total depth here is 3 meters. What else were we given? It is initially empty and is filling at a rate of 1 cubic meter per minute. So what would be our notation for that? What is that? 1 cubic meter per minute equal to in calculus notation.
dV over dt.
Okay, it's the derivative of volume with respect to time, so change in the volume. That is happening. All right, so far we got that. And then it is initial, how fast is the water level rising? Okay, so I need to identify some variables on here. So let's say we'll let W equal the depth of the water in meters. We'll let, and then so think about this. So as water is being poured into this, it is filling up down here. And I'm only going to color this 2-dimensional. So it's easier for us to see when we work with it. So water is being filled in here. You know, it is also still going in that 2nd dimension and 3rd dimension. But just looking at that, the water is being pulled into there. So I'm going to let, this is kind of forming a triangle, and that's the height of that triangle. I'm going to call this H. Okay. So we're going to let H equal the height of the triangle of the water, or the surface length of the water. So could have described it at that, or you can say this is the surface length of water in the pool. And this is also in meters.
What is that word after water?
Height of the water triangle. So if I'm looking at this triangle here, this is height and this is base. So that would be my height of that. Or you could say it's the surface length of the water. However you want to define that. So that kind of can be defined in different ways. Okay, so we have that going on. All right, so what do we want to figure out? What are we trying to find for the first question? It says, how fast is the water level rising 250 minutes after the filling begins? So we want to figure out how fast is the water level rising. So the notations I have here, what what calculus notation would I use to describe how fast the water level is rising? Okay, so we're trying to find dW over dt. And we're trying to find that after 250 minutes of filling. Okay. 200 minutes after the filling begins of the pool. Okay.
We just say T equals 250.
Yes, you can say T is equal to 250 minutes. Absolutely. Well, how can I do this? How can I, any ideas? Well, I got a derivative that's V, so that is volume. So I probably need a volume equation. Now, the problem arises is I drew the water level down here. What if the water level was up here? Because our volume of our pool, the shape of our volume, this is a right triangle prism, that is, but once you get up here, it's a trapezoidal prism that's being filled. So is there a way that I can figure out where the water level should be?
Draw a line so that there's a rectangular prism that's 1 meter deep, and then a triangle that's 2 meters deep.
Oh, okay. So we know this right here has to be 2 meters. This is still 50 here. Okay, so we can deal with this triangle. But again, how do I know I drew the water correct? How do I know the water is below the green line, or should it be above the green line?
It was empty.
It started empty. Oh, you could calculate the volume and figure out in 250 minutes, could we figure it? Could we fill out that complete volume of that triangle prism or not? So the first thing I got to do is figure out which shape we're dealing with. So if we're below that green line or above that green line. So let's find the volume of if the pool was filled to that green line. Okay, how would I figure out the volume of that pool was filled to the green line? What's our formula for volume there?
What is that she wrote? Right?
Volume of the green.
Oh,
Volume to that green line.
oh, that's an equal sign? Okay.
Yeah, volume to the green line equals. What's our formula for volume of that shape, a triangular prism?
Is it 2 or no?
So anytime you want to do a volume of a prism shape, you do the volume of that face. So, I mean, the area of the face. So we find the area of a triangle. How do I find area of the triangle?
What's that base times 3?
So 1/2, what's the base of the green? 50, and the height?
2.
So I got 1/2, 2 times 50. And then you times that by your depth. In this case, the width of the pool, which would be 20. And that gives you volume. Area of the base times your how many slices of those that you have. You have those 50 meters deep. Okay? So what do we end up with? 1,000. Okay? So that's 1,000 cubic meters. Is that, how do I know if my water level is going to be below or above that?
Well, you've got 1 a minute for 250 minutes.
Ah.
250.
So since I'm doing 1 a minute for 250 minutes, I know my volume has to be 250 cubic meters. Right? That's all the water I've been able to pull in because of my rate is 1. It's an easy one to do. And so, yes, I know I'm below the blue line. So that makes life so much easier that we're below the blue. We're below the green. So we can just do We don't have to deal with the trapezoidal shape. Yeah. All right, so let's, well, I guess I can keep that there. Okay. So let's see. We got the depth of the water. So that's W right there. We got the depth of the water is W. The height of the water triangle, or the surface area, the surface length of the water, is H. And we know that this green triangle, we've already figured out, is 50 by 2. So anyway, I can now relate, or any way I can find, well, how would I find the volume of the water? Let's start there. How would you find the volume of that water? What's the equation for the volume of the water now? We just did the volume formula. So what would be our formula for the volume of the water?
1/2 base times height.
So 1/2, what's our base letter? What's our letters for base and height?
W.
WH, so 1/2 W times H times by
20.
20. Okay, so that's our volume. So volume is equal to 1/2 of 20, that's 10 WH. Now, what rate of change do we know? What rate of change are we trying to figure out?
We know the rate change for the volume.
Okay, so we know the rate of change of volume, so I want to keep the V variable. And we want to find the rate of change of W. It's right here, dW dt. So H here is our problem type. So before I differentiate, I want to get rid of that H variable. And I want H to be written in terms of W, because I want that W variable in there. So I only want V and W. So is there any way I can relate H and W together?
Similar triangles.
You got to do similar triangles again.
W is equals to H.
So to our similar triangles, we see that in the water triangle, the blue triangle, we have W is 2H, as in the green triangle, 2 is to 50. W is to H, as 2 is to 50. So we're using similar triangles. Again, they're both right angles, and they both share that one angle, so it's angle-angle similarity, so we can do that. Cross multiplying, you get 50W equals 2H. Now, I want to write H in terms of W, so that means I need to get H by itself. So H would equal 25W. So I can go back over here. Notice I'm doing this before I differentiate to make life easier. And we won't get that extra rate of change that we know nothing about. So that's where you get stuck if you try to use the product rule there and differentiate. Okay, simplifying that down. Volume is equal to
250 W squared.
okay, so always rate of change. The rate I know, which you can't see now, the rate I know and the rate I'm trying to find, we need an equation that relates those two variables, and that's what we got. We're relating our V variable to our W variable. So that means I'm ready to differentiate. Okay, what's the derivative of V? 1 dV dt equals the derivative of 250W squared.
500W times dW dt.
500W times dW dt. So let's plug in what information was given, and we'll see if we can need to find anything else. So what do we know that we can plug in? 1 in place of dV dt. So that is 1. And we want to find dW dt, so that wants to be our variable. So I need to figure out W. Do I know W?
Um,
Or can I find W? What do we know that will help us find W?
So
Well, volume for the water form, the volume for our water, we simplify that equation, that volume equation down to down here to
250.
250 W squared, right? That was our volume of that water. Now, look at the given information. After 250 minutes of filling. So if it's been filling for 250 minutes, what would be the volume of the water? Because our rate of change is 1 per minute, so that's going to be 250. You agree with that? Okay, so that means W squared is 1. So W must be 1. Square root of 1 is 1. So that happens to be 1 there.
couldn't it theoretically be -1?
But what does W represent? The depth of the water. So you're not going to have negative
Okay,
depth.
I was just wondering.
So that's how you figure out which one applies. You're right, it is plus or minus 1. But the depth of the water, so it has, only one makes sense, the positive one. But good notice. Okay, so that means 1 divided by 500 is equal to dW dt. Right, now I need to figure out my units of measurements. What is W being measured in?
Meters.
Meters and time? Minutes. So that is 1 over 50, 1 over 500, sorry, meters per minute. And so your answer to the question would be, the water level is rising at a rate of 1 over 500 meters per minute. Your sentence answer. Okay, how long will it take to fill the pool? Part B.
We need to do
So what do we need to figure out how long it will take to fill up that pool? The volume, just the volume of that, right, trapezoid prism. Okay, so the volume of a prism, trapezoid prism is 1/2 the sum of the bases. So my bases would be the parallel sides, so that's 3 and 1. So that's going to be 3 plus 1. Times by that height in between the two parallel sides of the trapezoid, so that's 50, times by the width of the pool, which is 20. So I'm times that by 50, times that by 20. So 1/2 of 2 is just 1. I mean, 1/2 of 4 is just 2, sorry. 1/2 of 4 is 2. And then times by 50, times by 20. Well, 2 times 50 is
Uh-huh. 2,000.
gives you what?
2,000.
2,000. Okay. And volume is cubic meters. Okay, so we know that the pool contains 2,000 cubic meters, and it is filling at a rate of 1 cubic meters per minute. So how many minutes would it take for it to fill? 2,000 minutes. So. questions over that one now?
So we have this. Okay.
Okay, any other problems on the homework?
What did you do? 5?
5.
Just the summary.
Okay, so number 5. A surface ship is moving horizontally on a straight line at 10 kilometers per hour. At the same time, a enemy submarine is positioned directly below the ship while diving at an angle of 20 degrees below the horizontal. How fast is submarine altitude decreasing? Okay, so here's our ship, and here is our submarine, and this is it's traveling in this, ship is traveling there, and so the submarine is angling down at an angle of 20 degrees. So this is one example where we use degrees instead of radians, since it was given in degrees, these application problems. So let's identify some things on here. So let's say I'll let X here represent the distance in kilometers the ship traveled. And I'll let A equal the altitude of the submarine below the ship, the submarine. Okay. Our units are all in kilometers. It was given in kilometers. Okay. So what rate of change was given to us?
10 kilometers.
Yeah, the surface ship is moving at a straight line at 10 kilometers per hour. So what would be our notations for this 10 kilometers per hour?
dx dt.
All right, so we know dx dt. And the question asks us, how fast is the submarine altitude decreasing? So what are we trying to find?
dA dt.
Okay, so we're trying to find dA dt is what we're trying to figure out. All right, so that means I need an equation that relates x and a. So what equation could I use that could relate x to a? Dylan, and I probably won't use that. They gave us that 20 degrees for a reason. Think trig. Tangent. Okay. We know tangent of 20 degrees. Tangent is equal to opposite over adjacent. So that means that's going to be a over x. So tangent of 20 degrees is equal to a over x. Since I want to find dA dt, I can go ahead and solve this and get that's x times tangent of 20 degrees equals a. Now, tangent of 20 degrees, is that a variable or is that a constant? That's a constant. So this is just a number times x equals a, is what my equation is here. So how would I differentiate that?
You would pull out the constant and find the derivative of x.
And very good. So I got my constant here, which is tangent of 20 degrees. And what's the derivative of x?
dx over dt.
Very good. So that's times by dx over dt equals
dA over dt.
dA over dt. All right, so I'm relating the derivative I need to find with the derivative I know. So let's just substitute in. So tangent of 20 degrees times by 10, which is our dx dt, is equal to dA dt. And so in my calculator, making sure, well, actually, the book just left it there, didn't it? Okay, so 10 tangent of 20 degrees. And then what is altitude being measured in? Kilometers. And what is time being measured in? Hours. So that's kilometers per hour. That's how you can find your units of measurement for that.
It's also like around 4.6 or something like that.
Yeah, plug it in, but make sure when you plug it into your calculator, make sure you switch to degree mode. Make sure you're in degree mode. I didn't check it. Let me check what that is.
3 points.
Is it? I gotta switch over to degree mode. Okay, so 10 tangent of 20. Yeah, 3.64 or 3.6 kilometers per hour would be what that would be as rated. Okay. Any more? Homework problems? Okay, so next Monday we have our test. What's our test going to be over on Monday? Okay, the implicit differentiation, related rates, and I originally said the mean value theorem and the linear approximation that you watched the videos on. But after talking to a few students yesterday, I'm thinking that today we're going to spend another day practicing related rates. I think we need another day of practice on that. And so I'm going to change the test to only cover implicit differentiation related rates. Thursday, we will do what you watched the videos over last night on the linear approximation and the mean value theorem, but that will not be on the test. So I'm changing the test slightly to just these two topics. So I want to give you an extra, I think we need an extra day of practice. Okay, so let me assign. I made a second worksheet last night over related rates. So I just published it. It's related rates, worksheet number 2. Now I gave you lots of problems. I'm only requiring you to do for homework the odd problems. 1, 3, 5, etc. I went ahead and gave you the even ones as well in case you want extra practice as you're studying for the exam on Monday. And again, at the bottom of this worksheet, I put the answers for you to check how you're going on it as you go through it. Okay, so that's what we'll work on today. So related rates number 2, and we'll postpone talking about the mean value theorem.